is the Friday, March 27th tutorial. So a question I've had is how is the test going to work? So first off, I'll cover what we're going to be looking at on the test. So just simple wave equation, speed of the wave is wavelength times frequency, reading waves on a graph. So you need to be able to read things like amplitude, wavelength, period, things like that you're going to need to do for the test. So that's one thing. Another thing we're going to do is intensity. Intensity is the whole power divided by surface area of a sphere. So dealing with our intensity equation. So what intensity will a sound be at a certain distance, or if I have a certain power intensity, how far away could someone hear it? So things like that. We also have the Doppler effect. Doppler effect, which is the whole frequency heard by someone is the frequency made by a source times the speed of the wave. Most often this is going to be the speed of sound in air, plus minus the speed of the source, the speed of the detector, speed of the detector divided by speed of the wave plus minus speed of the source. And then just this whole thing about frequency goes up if you see anything about the word towards, and then frequency goes down if you see away from. And then you have to kind of think about what happens. Plus in the numerator to make the number big, but plus in the denominator makes the number small, things like that. So Doppler effect. And then the last thing is going to be standing waves on strings. So you're going to have to know the harmonics and overtones. And then we have the equation that we were using most in our lab. The speed of a wave is equal to the square root of the tension times the length of the string divided by mass of the string. So 4 questions. I'm just going to tell you pretty much one question over each of those topics. So be looking through those, look at previous things we've done. I'm trying to go through and grade homeworks. It's been kind of difficult keeping up. It's a lot more work grading homeworks online, so I'm going to try to get through those more. The test review answers, I'll probably post those on Monday before class at some point, so work on the test review. It talks about all of those. Your test will be Wednesday. I'll post it at some point in the morning, probably at around 7:30 to 8. At 10, I'm going to log on like I normally will, just to kind of work through a few of the instructions. Some of the instructions might be a bit confusing on there. My way I chose to kind of randomize the test. So I'm going to log in at 10 to work through certain points and answer questions if you're confused about part of it, because I do expect some confusion on the actual test itself. So yeah, just be there to answer those, and then I'll post that online. Because I know people are working on a lot of different situations. Some people are having to share computers. Some people are having to find a place with internet. Some people only have a phone. The test is just going to be posted. It's going to be a PDF. You're going to work out your work nice and neatly on a piece of paper, and then you'll just upload a picture of each page with your name and pin at the top. So you'll have all day to do it. I don't feel comfortable giving you a time limit within the day to do it, because then some people just won't be able to work within that time limit. So you'll have all day to do it, but I'm not planning on taking any tests submitted like outside of that day unless you have some reason that you're able to tell me about. So if there's something that comes up next Wednesday, just please email me. I can work with you if you tell me what's happening. But yeah, you'll have all Wednesday to do it. So any other questions on the test before I start talking about the lab? Yeah, you can still wake up at 1 p.m. So at 10 a.m., I'm going to record the instructions, even if no one logs in. I'm assuming some people will log in, but yeah, I'm going to record myself working through the things I think might confuse you that are more procedural as opposed to solving the questions. So I'll work through those with you. They will get posted on YouTube, which you can watch through Google Classroom, so you can still wake up at 1 p.m., watch that video, work on the test, and get it turned in before 11:59 p.m. Yeah, any other questions on the test before I talk about the lab?
I don't know.
What was that?
This is how it is.
I barely heard what you said. All right, then. So if there's no more questions about the test, and again, you can also ask more questions about the test on... Yeah, so on Monday, we'll still have class, and we'll have a short little lab, the thing with the water bottles. So make sure you have a water bottle. Also, if you have a ruler, you're going to need a ruler. If at least one person per group has that, it should work. So yeah, so let's look at the lab then, if there's no other questions. So number 5 on the lab prediction sheet. All right. So yeah. So yeah, 5 is talking about how many harmonics are possible for the setup. So think about the minimum mass possible being the hanger without coins. So what's the mass of the hanger in grams? So the hanger is a mass of 9.54 grams. So what's going to be an issue? Like if I solve all of my equations and I get a mass, were the masses going up as I got to higher harmonics, or were the masses going down as I got to higher harmonics? Yeah, the mass was going down, and we saw that from our equation because wavelength times frequency is equal to the square root of tension times length divided by mass. And this is of the string. So we saw that this is equal to our speed. We saw that our wavelength was going down with a constant frequency, which meant our tension had to go down. The length of the string stayed the same, and the mass of the string stayed the same. So we kept decreasing the mass. Eventually, we're going to reach the point where I can't go smaller than the mass of the hanger. So that's one way of answering the question, is that this is the smallest possible mass I can hang, and I can't go below this. If you wanted to, you could also look at the mass of a dime, because if I really wanted to, I could just tie a dime to the end of the string, and the dime was, what, 2.268 grams, somewhere around there. So you could either say, oh, well, the hanger is this mass, so I can't do any harmonic that would say I need a mass lower than that. Or if you want to, you could try to figure out, hey, I could use as small as a dime, so what's the longest harmonic I could do with that? So either one of those would be fine. Just which mass do you get to that's below one of these values? And I don't care which one you choose, as long as you explain why you chose that one. Does that kind of make sense? All right. And then, so how do we do the evaluation for the lab? Do you mean how do you answer it? So the plan was that you collaborate either through texting or phone calls, or you could even have a Google Meet session like this. You can form your own. So you can either print it out and write on it, or you could uh, download the Word document and type into the Word document, or you could just write in a piece of paper neatly like this. Any of those should be just fine. And then if you wrote on paper, just take a picture of it and post one per group to Google Classroom. And then, yeah, some of this, I was planning on doing the procedure and evaluation differently. I was planning on doing it one class and the next until I started really thinking it wasn't going to take that long. So the evaluation of data, we did kind of some of the evaluation already. Um, so yeah, we already did the procedure and I tested most of these values, and then you can compare them. Um, One question was, how do you do the percent difference if I did the values and I already tested? So yeah, experimental tension and wavelength. So the experimental tension, well, the experimental wavelength is going to be exactly the same as your actual wavelength. Um, there's just that's just how it is. So your experimental wavelength and actual wavelength are going to be identical. The tension is going to be a little bit different. So when you solve for force of tension, you can get an exact number whenever you're solving for this, the prediction. So you can solve for that, get an exact number, and that should be fine. And then whenever we test that value, we're going to get a tension is going to equal to the mass of the coins times acceleration due to gravity. So we're going to see that this number is going to be slightly different. It's not the best analysis doing a percent difference between those values, but we can still practice doing a percent difference more so you know that you should kind of do it. It's not the best analysis of data. Yes, you do need to include the container. So yeah, so I should probably write that mass of coins and container. Yeah, or this whole thing is just the hanging mass. And again, a really subtle thing to just kind of remember is when I'm doing tension hanging off the edge, it's going to be the hanging mass times acceleration due to gravity. But in this equation here, it's length of the string and mass of the string. So just something to kind of keep in mind every time I'm looking at this speed and a wave equation: length of the string, mass of the string. Other questions on that? And then number 6 on the evaluation, uh, you can't really do that. Again, that was me expecting to do this the next class after we tested it again, so we can't really do that. So yeah, you don't have to do number 6 on evaluation. We can skip that. Yeah, you already have the wavelength. Uh, that's a limit of you're going to have to. I guess I could sit there with a ruler and measure all of them, um, but that would be kind of difficult to do. It's going to just end up being exact uh, half wavelengths for each one. So it's all going to be you just measure the entire length and then figure out how many wavelengths and go from there. So yeah, your experimental and your predicted are going to be the exact same on that one. Yeah, you already have your wavelength. Anything else on the lab? And yeah, I know I had a lot of individual things to turn in the lab with. Let me see. Let me. Yeah, I had like the prediction and evaluation differently. I'm going to delete this evaluation of data. So the prediction, yeah, we just have one. Yeah, I'm going to delete the evaluation. So yeah, the prediction, just put your prediction and evaluation. I'm editing that right now. That'll be page 2, 3. Uh, did I say the evaluation is due Monday? I accidentally deleted. Would you like another day to work on that? I can give it till Monday. Yeah, I'm changing that right now. Yeah, sorry for all these random things that might be confusing. I'm also trying to figure things out on the fly and figure out what works and what doesn't work. So, yeah, we'll make this due Monday at midnight, and then for prediction and evaluation. So if you already turned in a prediction, just also include the evaluation on that same page. Uh, the prediction and evaluation. You just turn those in together. It'll be easier to grade, anyways. So yeah, I'll give you till Monday. And I'm also trying not to be. I know a lot of people like. I don't know what all of your technology situations are. I'm trying not to be too terrible with late assignments as long as you're getting it in close to on time. Uh, you can unsubmit. I don't think you even have to unsubmit it. I think you can just go in and submit a different thing. But yeah, you can. It shouldn't be an issue. I know a lot of people go in and edit their assignments all the time. I don't know what your side of the interface looks like, but people edit their assignments all the time. So yeah, just the one lab group prediction and evaluation. You'll put that in. But just on the prediction, make sure you show all the work. And then I still want each individual person to do a self evaluation for your group. Yeah, you already have everything you need to complete the lab. So we already went through, we already did the testing, we already did everything. Other questions on the lab? Like any specific one that was giving you trouble? And then for those of you that are in MST in here, I haven't fully made your MST project, but it's going to be a continuation of your lab you do on Monday. It's not going to be too difficult. Just on Monday, you're going to be um, using a bottle to find the speed of sound, and the MST project is just going to be you doing the similar thing in order to uh, pretty much just make instruments and try to tune it, and then maybe try to do a song or at a minimum show your tuned instruments. I think it should be pretty straightforward, not too much math, and hopefully a little fun. Are you talking about 1A on the lab or on the review? Oh, the lab. 1A. Yeah, so does that include the container too? Yeah, so that's what I was talking about up here. How many harmonics were possible? So with the hanger on there, what was the lowest harmonic we were able to go to with the setup? Yeah, so the lowest harmonic we were able to go to was the third harmonic. So this is evaluation number 1A. We were able to get to the third harmonic with just the hanger. And one thing that you might see, I forget the exact number we calculated for that. I don't have that right here with me. Uh, but whenever we get to really low masses like that, friction is starting to have a bigger effect on the tension in addition. So you have other forces. And so the value you get might be slightly different than that. So yeah, we were able to barely get the third harmonic with just the hanger. So it should be somewhere around that value. That's our limit. But you could also just predict if I were to sit there and only tie a dime to the end, what harmonic could I get down to? 1A is like 5. Yeah, so 5 was your prediction, and then 1A was a test of the prediction for 5. So normally when we do a lab, you should make a prediction and then test a prediction. That's kind of the whole scientific method. You set up a model, you try to figure out the prediction your model can make, and then you test it. Um, it just doesn't always work out like that in class. It was a little bit better, I think, in my opinion, to just do kind of the whole thing at once. Then you go through and then you use your math and then you're testing your math. So it's a little bit backwards of what we should do, but it's still useful. Um, can we expect to use a prediction wavelength for 3? Whoa. So you're talking about predict the wavelength and tension for the third harmonic and show your work? Whoa. What do you mean by can we expect to? Yeah, so that's why. So you predict all of your mainly tension, right? Again, it all really goes back to, is my tension going to be below the value I could get? And so that's why I had you predict first through fourth harmonics, and then you should go through and you should find, hey, one of these is not going to work with the tension. Um, so that's fine if you're saying with the hanger I was able to get to the third harmonic. If you really want to go a little bit further, you could try to figure out, well, the smallest mass I could get down to is a dime. So if I were to just use a single dime hanging from there, how many harmonics could I get to? So that would be an interesting thing. But then if you were to do that, then you couldn't really answer 1A as in because we didn't really test that. But that would be interesting nonetheless. Anything else on the lab? Okay, so tension. Yeah, tension is the one that you should worry about. The wavelength, there's no real limit on the wavelength because wavelength keeps getting smaller and smaller. The limiting factor on the wavelength is how long you can make it. So the wavelength is only limited by the length of the string. I can only make the wavelength based on the length of the string. The first harmonic is going to be half a wavelength. So the biggest wavelength I can possibly make is going to be twice the length of the string. So my limitation on wavelength is how big I can make it. But as I go up in harmonics, my waves get smaller and smaller. So there's no real limit we have in this class about how small we can make the wavelength. So there's nothing stopping us from having like the 1,000th harmonic with 1,000 tiny, tiny little waves in there. It'd be really difficult to achieve. Uh, but yeah, the limiting factor isn't going up in harmonics when it comes to wavelengths. The limiting factor is going down in harmonics when it comes to the wavelength. And so yeah, tension we had to keep getting smaller and smaller, and we reached a limit of based on just the things I had laying around my house was the smallest I could get to. This tutorial is getting recorded. It normally takes about 30 minutes to an hour for it to go into Google Classroom, depending on how long this goes for. But yeah, you'll be able to look back through this. Any other lab questions? Any review questions or So either questions on the review I put up or questions on any topics we've covered so far. Yeah, I mean, I figured most people haven't looked at the review yet. Just make sure you look at that pretty soon. I mean, the test will be Wednesday. We'll have class on Monday, which will be you doing a lab. And then we will have a tutorial on Tuesday. The next lab is going to be a lot more straightforward than this one. So don't stress about that one being so bad. I kind of really walked you through the steps as opposed to this one. I was making you think a lot more. But yeah, so work on that and I can answer questions on the test review. Four on what? 4 on the lab, 4 on the test review. Let's see. All right. So for a tuning fork has a known frequency of 440 hertz. A guitar player is tuning his guitar and notices a beat occurs every half second. What is the frequency of the beats, and what two frequencies could his guitar be at? Now, I'm just gonna say I thought about removing that question, or that's not going to be on the test, but it's still a good thing to look at. We did some work on it. I don't think I put a question like this on the test, but yeah. So the first thing it wants is the frequency of that beat. So frequency is frequency the number of waves per second or the number of seconds per wave? Or here it'd be beats per second. Is it beats per second or seconds per beat? Yeah, per second. Just think of the units. Hertz are 1/2. So I need number of beats per second. So I have 2 beats. So a beat occurs every half second. So if the beat occurs, I could write that. I could write 1 beat per every half second. 1 divided by a half. How many times can I add 1/2 together to get 1? Two hertz, right? So I have 2 beats per second. If one happens every half second, then 2 of them happen per second, right? Hertz is just per second. So every time you say hertz, you can just think of saying per second. Oh, that's all right. I sometimes can't tell if people are like genuinely unsure, just not like doing other things, or how many people are like actually watching. Like sometimes my microphone turns off. All right. So then the frequency of the beat is just going to be the difference in the two values, frequency 1 minus frequency 2. That's all pretty much just saying that the frequencies are going to be off by 2 hertz. So if the tuning fork is 440 hertz, it needs to be up 2 or down 2. So the frequency is going to be 438 hertz or 442 hertz. So it's either going to be above or below. Yeah, it is really hard to tell if people don't know the answer or if they're just too shy to answer or if they're just have me up in the background. This honestly makes me not understand how anyone would ever want to do any sort of like vlogging or YouTube Live or just anything like that. Yeah, I mean, I definitely would like you to unmute yourself and ask questions. Um, but a lot of people just seem really reluctant to it. The graphs on number one confused me. Yeah, I was expecting that. Hello, Joseph. That's when I stream. Yeah.
Mr. Beverly,
Hi.
how's your morning been?
My morning was pretty
Yes.
good. My wife got me Whataburger for breakfast, and then we did AP tutorial or AP class, and so yeah, not so bad.
Nice.
Tried to grade the take-home test. That's been a giant pain. All right, so my wife went out of the house. I mean, she stayed in her car. The CDC says if you go somewhere, you're supposed to, like, you should at least do drive-through. She's also, what do they call it, an essential worker because she's like healthcare professional. She does like counseling, psychology for people, sees clients. So yeah, she still is an essential person who can actually go to work, even if they did a lockdown. All right, so we have two graphs. What's the difference between these two graphs? So one is position time on the left. What's the other graph?
Distance over position.
Yeah, the other one is that vertical, the position, versus the horizontal distance. So one is looking at the position of the wave over time. The other one is looking at the position of the wave on the y axis and the position of the wave on the x axis. So when we're getting wavelength, first of all, wavelength, which axis are we looking at, the x or the y?
The x.
X. So if we're looking at the x axis and we need a length, left graph or right graph?
Right.
Yeah, so the right graph. So for A, we want to look at the x, the y position versus the x position down here.
Is that because it's distance?
Yeah, because it's distance, position, wave length. And so it's here. Now, if I start here, that's at a trough. Where does my wave end? Where does the single wave end?
At the other bump.
Yeah, at the other negative. It has to get to the trough, right? And then, so what is this position?
The wavelength.
Yeah, I mean, from here to here, so my wavelength is 2 meters.
What's a crest?
Crest is the top. Crest is the top, trough is the bottom.
What's in the middle?
The middle is the equilibrium position.
Okay.
And then B wants us to get period. So
B,
which graph
left
am I
graph.
going to... What's that?
The left one.
Yeah, that's the left one, because my left graph has... It looks really similar, but we really need to be careful to actually read what they say. So this is versus time in seconds versus my y position in centimeters. Looks really similar. And by the way, there is nothing stopping me from going from crest to crest, right? From, where is this one at? From 1 to 3 meters. It's still 2 meters apart from there to there. So you have the same thing here, from here to here. So we start at 0 seconds, and this ends at 3 seconds. So we have a period of 3 seconds. Frequency, I think you should be able to do frequency pretty well. Hopefully, frequency is just 1 over period. And then to get the speed, again, I think speed, most of you should be able to do just fine. Speed is wavelength times frequency. So just wavelength times the frequency you get here. E, amplitude. Amplitude is the one thing, the next one that I think could mess people up. Which graph can I get amplitude from?
You get it from the right graph, right? You can get both.
Yeah, I can get it from either graph, right? Amplitude is my y value. If we notice, both of these go up and down between the same y value. So amplitude, we go from -3 to +3. So is amplitude that entire 6?
No.
Yeah, amplitude is only from our equilibrium position down. So our amplitude is from here to here. So our amplitude is, and make sure you give the right units, what's our amplitude?
3.
3
centimeters.
Yeah. So obviously the graph's not to scale, but yeah, 3 centimeters. So there definitely is going to be a question like this where you do have to read an image of a wave. And again, the first thing you really should do is read your axes. Position time, or is it position and position? Obviously, you'd use the one with time to get period, the one with position on the x-axis to get wavelength. And I could easily ask you to get period from that and frequency, or I could also just give you something about how many waves happen per second or different things like that.
Mr. Beverly.
Yes.
Why you wrote x centimeters, but you put meters for wavelength?
Are you talking here?
Yeah.
That's a parenthesis.
Oh.
But yeah, our x-axis is in meters. And our y-axis is in centimeters. So obviously not to scale, not drawn to scale. And I intentionally changed those just to see if people are actually reading. But yeah, I do things like that a lot in the test. Not so much because I'm trying to trick you, but it's just make sure you actually read what you're looking at as opposed to assuming.
Is there going to be like a lot of concepts on the test?
Not so much concepts. It's mostly going to be, there's going to be a decent amount of math. I mean, there's always some concepts, but because it's only the free response, because I didn't want to deal with putting in every single multiple choice or having to try to grade those individually, it's more math. The multiple choice is a little bit more concepts, but there's always concepts embedded in the math, if that makes sense. The evaluation page of the lab. Which part on the evaluation page? So the experimental wavelength and tension. So your experimental wavelength is going to be the exact same as your predicted wavelength as long as you predicted correctly, because that's all just completely dependent on the length of the stream. So experimental wavelength is going to be identical. You get your experimental tension by your experimental tension is going to be the mass of the coins and containers times 9.8 meters per second squared.
Wait, for experimental wavelength is based on the length of the string?
Yeah, so the experimental wavelength is just, I didn't go through and measure each one. I guess I could have sat there with a ruler and measured each one, but I just found the number of them. Yeah, so you are going to find the experimental and theoretical wavelength are just going to be identical for you.
Oh, so prediction and experimental is basically the same thing,
For wavelength, yes.
but the tensions are different.
Yeah, the tensions are going to be a little bit different. Mostly it's just because you can get an exact prediction for tension. But when I tested it, I only had set values of masses I could add. And so because I only had set values of masses I could add, you're going to see that your tension in the test, your experimental tension is going to be different than your predicted tension.
So the test is we gotta try to get the closest points to the tension.
Yeah,
Force or
because
something.
we only had so many ways we could combine the coins, and so yeah, we weren't going to be able to get the exact value that we predicted. So that's a limitation. So we are going to end up with different tensions.
So we just try to get the closest one.
Yeah, try to get the closest. So well, we already did the test though.
We did.
Yeah, this was what we did in class. So we went through, we found the exact number of coins.
Oh, when we found the number of coins, right?
Yeah, so we found the
That was the
coins
test.
and the hanger. I have this somewhere. No, this isn't it. Yeah, so we went through and we calculated, say this was a third harmonic, we calculated a certain amount of mass, but we had the mass of the container was just for the third. But for the, say for that first harmonic, we, so we figured out that we needed 25 grams. And so we were trying to figure out how much to add to that, but we had to end up adding a different amount. So we wanted 25 grams, but we got there by adding, what did we end up doing? We had the,
What's
yeah,
that?
I didn't write it on here. I don't know the exact number of coins I added, but that should be in the lab. So yeah, you're going to go through and do the mass of the hanger plus the mass of the coins in the hanger. That's going to be my experimental. And then our theoretical is what we actually calculated what we should get.
Oh, so we. Oh shoot! I already did that in the predictions.
Oh. Yeah, that's fine. If you did the work on the prediction for the amount of coins, then that's your prediction, and then you'll go through and you'll actually write what we actually hang, how many coins I actually had when I sat there. I think for the first one, wasn't it like 19 nickels or something, or 18 nickels? And so that's the actual where you just add up the mass of all the coins and the container and multiply that by 9.8.
Son, does that make more sense?
See, we don't know if he just randomly. There he goes. Yeah, we have to convert the coins from grams to kilograms, then multiply times 9.8. Yes. And also make sure to add in the container. The container had the mass of 2 dimes and a nickel.
Wait, we're supposed to convert it?
Yes, you need to put this into kilograms. We need kilograms times meters per second squared to get newtons.
Oh,
Meters,
okay, that makes
kilograms,
sense.
seconds. Anything else, or is that a little bit more clear now?
That made things a lot more clear now.
All right.
I think that's all the questions we have. I assume.
I assume, yeah, it seems like people kind of got their questions answered, and I think most people have been linking. Well, if that's it, this will be posted probably 30 to 45 minutes from now. Other than that, yeah, have a good weekend. I'll see you Monday morning. We'll go through it. We'll have another little bit easier lab. Just make sure if you have a ruler, find it, get a hold of it, and your plastic bottle, and we'll go through that. But yeah, everyone have a good weekend. Bye.
Okay, you too, Mr. Beverly.